Chapter 5, Lesson 6, the coordinate plane. You will be able to locate ordered pairs. A coordinate plane is formed when the x-axis and the y-axis intersect at their 0 points. The axes separate the coordinate plane into 4 regions called quadrants. 1, 2, 3, 4. You can use the location on the plane or the x-coordinates and y-coordinates to identify the quadrant in which the point is located. A couple things about this graph before we get started. Now, really, your x-axis, if you look, the horizontal from left to right, is a number line. Zeros in the center, 1, 2, 3, 4, 5, and then -1, -2, -3, -4, -5. The y-axis is also a number line. It's just a vertical number line. Again, there's 0, and it counts up 1, 2, 3, 4, 5, and counts down until -5. When numbers aren't written in, it is understood that they count by 1 unit. So we will come across some grids that will not have numbers on it. They count by 1. There's also this special point right here in the very center at 0, 0 that is called the origin. Okay, so the x-coordinate is 0 and the y-coordinate is 0. In fact, coordinates are x, y, and all you're doing is naming each coordinate with a number. A nice way to remember that x comes before y is because x is before y in the alphabet. Now, coordinates or ordered pairs must be shown as 2 numbers in parentheses with a comma separating them. So these are all coordinates or ordered pairs. Quadrants. We start where both x and y values are positive. So anywhere in here, I'm going to have positive x values and positive y values. That's quadrant 1. Notice how it's labeled. It's labeled with a Roman numeral. It must be labeled with Roman numerals. You cannot use numbers. Then we go counterclockwise. Quadrant 2, quadrant 3, quadrant 4. So in quadrant 1, your x and y coordinates are positive. So 2, 5, which is right here. We'll label it in a different color here. So 2, 5, which you'll learn to graph in the next lesson. That's in quadrant 1. It names your x. Oops. It names your x and your y. Again, x, then y. So your x value of -2 and your y value of 5, here's x of -2, y value of 5, that's in quadrant 2. So your x coordinates that are negative, your y coordinates that are positive, are going to be in quadrant 2. If they're both negative, they're going to be in quadrant 3. And if the x coordinate is positive but the y coordinate is negative, it will be in quadrant 4. So there are 4 different quadrants. If a number, or a point I should say, winds up on any of these axes, it is considered to have no quadrant because it's on the border. We have no idea whether or not this point is in 1 or 4. So we simply say it has no quadrant. Let's do some examples here. Use the following diagram to help you answer the questions below. Identify the ordered pair that names point C. Then identify the quadrant in which it is located. Now remember, quadrants, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you want to label your graph to start, there is no problem with that. Name point C. Well, in this case, if you look at our x and y number lines, or x and y axes, they're actually counting by halves, which is okay. They can count by any number as long as it's consistent. So my x value is 1 1/2, so I'm going to write that first. 1 and 1/2. So this is my x value. And my y value, if I go across, is positive 1. So this point is 1 and 1/2, comma 1. And it is located in quadrant 1. Letter B. Identify the point located at -1 and 2. Actually, this was a typo. If I remember correctly, this should be 1/2, so please fix that. -1 and 1/2 and -1. So this is our x value. This is our y value. So let's find our x value of -1 and 1/2. That's here. And our y value of -1 is here. So if we follow these 2 points to where they meet at point B. And this is in quadrant. Let me rewrite that B a little bit better so it doesn't look like a 13. There we go. And this is in quadrant number 3. You can make your quadrants as normal sticks, or you could put the lines above and below if you'd rather. It's just preference. Letter C. Identify the ordered pair that names point A. So here's A. Make this a little thicker again. Here's A. We want to know its x value, so let's go down to the x line. Looks like -1. And we want to know its y value, so go to the y line. Looks like 1 and 1/2. And this is in quadrant 2. Letter D. Identify the point located at 1, -2. Remember, this is x and y. Then identify the quadrant. So 1, -2. Let's actually make this a yellow. So here's our x value of 1, and our y value is -2. -2 is down here. So if I follow this along, and then follow my -2 along, it winds up at point E, which is in quadrant 4. So E in quadrant 4. Letter E. Identify the ordered pair that names point D, then identify the quadrant. So let's use blue this time. So we're looking at point D. We want to know the coordinates, or the ordered pair. So if we go up to x, it's 1 and 1/2. And if we go over to y, it's -1. So 1 and 1/2, -1, and it is in quadrant 4. Reflections. You can use what you know about number lines and opposites to compare locations on the coordinate plane. Consider the number line and coordinate plane below. The number line shows that -4 and 4 are opposites. So here's our 0. 4 is 1, 2, 3, 4 spaces away, and -4 is 1, 2, 3, 4 spaces away. Those are considered opposites. Now, if this were the x-axis, like down here, this would be 0.4, 0, because it's right on this line, so the y value is 0, the x value is 4. And over here would be -4, 0, because the x value is -4, and the y value is 0. Now, they are considered to be reflected across the y axis. Okay? Let me make that a little bit smaller. That was a lot bigger than I anticipated. We'll do this one. There we go. It was reflected over the y-axis. Now, it was reflected over the y-axis, so the y value of 0 did not change, but the x changed to its opposite. So let's actually jot this down. When a point reflects across the y-axis, and let me make this font a little bit smaller, the y-coordinate stays the same, and the x-coordinate changes to its opposite. Similarly, when a point reflects across the x-axis, the x-coordinate stays the same, and the y-coordinate changes to its opposite. Jot that down, and we're going to then do a couple examples with it, just so you get a clear understanding of what that means. Name the ordered pair that is a reflection of -3, 2 across the x-axis. We're reflecting across the x-axis, therefore my x value of -3 remains the same. But then what I need to do with this y value is change it to its opposite. Its opposite is -2. Let's do it again. Again, we're reflecting over the x-axis, so my x-coordinate stays the same. My y-coordinate changes to its opposite, which is 4. Letter C. Again, reflecting across the x-axis, therefore my x-coordinate stays the same, and my y-coordinate changes to its opposite. Letter D, reflecting across the x-axis, my -3x coordinate stays the same, and my y-coordinate changes to its opposite, which is 1. Kendall is building a square fence. She places fence posts at the locations indicated on the grid. What is the location of the post that reflects -4, 4 across the y-axis? Now, there's not a grid in this problem, but it's not needed. So we're reflecting over the y-axis, so my y-coordinate stays the same. And the x-coordinate of -4 changes to its opposite, which is +4. Letter F, Kendall also placed a fence post at -4, -4. What is the location of the point that reflects -4, -4 across the y-axis? Again, my y-coordinate remains the same, but my x-coordinate changes to its opposite. And remember, x, y.